July 2, 1941. 25 kilometers south of Berlin at Kummersdorf Proving Grounds, Oberingenieur Wolfgang Fischer's pencil stopped moving mid-calculation. For the third time that morning, he rechecked his measurements of the captured Soviet T-34's armor plate thickness. The numbers defied everything German engineering doctrine held sacred. The tank's frontal armor, sloped at 60 degrees from vertical, provided an effective thickness of 90 millimeters while using only 45 millimeters of actual steel. German tanks achieved similar protection only with 80 millimeters of vertical armor, nearly twice the weight. Fischer stared at the green-painted tank, its camouflage still bearing scars from the fighting near Grodno 8 days earlier. In his 20 years designing military vehicles for Henschel and Son, he had never encountered such elegant simplicity, achieving such devastating effectiveness. This moment marked the beginning of Germany's most profound military technical crisis of the war, one that would shatter assumptions about superiority and reshape the entire German tank program. The T-34 had arrived at Kummersdorf after being captured intact on June 24th, one of the first specimens taken during Operation Barbarossa's opening days. Germany's finest engineers now swarmed over it like archaeologists discovering an impossible artifact. What they found would trigger a crisis of confidence that reverberated through every German tank manufacturer. The mathematics of armored warfare were being rewritten by a nation the Wehrmacht had dismissed as technologically primitive. The first encounter had occurred on June 23, 1941 near Grodno, when Oberfeldwebel Klaus Weber of the 7th Panzer Division met the future of armored warfare. His Panzer III platoon spotted a lone Soviet tank approaching across an open field. Weber ordered his gunner to engage at 500 meters, a range where German marksmanship typically guaranteed destruction. The 37mm armor-piercing round struck the Soviet tank's turret and bounced off harmlessly. Weber ordered rapid fire. 7 more rounds struck the approaching tank, each one ricocheting into the sky. The Soviet tank continued advancing, apparently unaware it was under attack. At 200 meters, the Soviet tank's gun fired once. The Panzer III to Weber's left exploded. Its 30mm armor penetrated completely. When Weber examined the knocked-out vehicle after immobilizing it with a track hit, he found 29 impact marks from German shells. Not one had penetrated. This was the Wehrmacht's introduction to the T-34. Within days, similar reports flooded in from across the entire Eastern Front. Panzer crews described Soviet tanks that seemed immune to German weapons, that could traverse swamps where German tanks bogged down, that appeared suddenly from forests German commanders had deemed impossible for armor. The scale of the crisis became apparent through ammunition expenditure. In the first 3 months of Barbarossa, German forces fired more anti-tank rounds than in all previous campaigns combined, yet tank-kill ratios remained dismally low. A study by the Wehrmacht's Statistical Office in September 1941 revealed that German tanks required an average of 13 hits to destroy a T-34, while T-34's typically destroyed German tanks with 1 to 2 hits. This 13-to-1 disadvantage in ammunition efficiency had catastrophic implications for German logistics already strained by the vast distances of the Russian front. General Heinz Guderian, architect of German Blitzkrieg doctrine, personally investigated these reports near Metzensk on October 6, 1941. What he witnessed challenged everything he believed about armored warfare. A handful of T-34's from Colonel Mikhail Katukov's 4th Tank Brigade attacked the 4th Panzer Division, destroying dozens of German tanks while suffering minimal losses. Guderian watched through binoculars as German 37mm and 50mm shells bounced off T-34's at point-blank range while return fire from the Soviet 76.2mm guns destroyed Panzer III's and V's with single shots at distances exceeding 1,000 meters. In his memoir, Guderian wrote with unusual candor about this engagement. The rapid advance on Tula, which we had planned, had to be abandoned for the time being. Our casualties were too severe. What made things worse was that the enemy's new tanks were superior to ours in armor and armament. He noted that the short-barreled 75mm gun of the Panzer IV was effective only if the T-34 was hit from behind on the gearbox, while neither the 37mm nor the 50mm gun could penetrate the T-34's armor at normal combat ranges. Meanwhile, the Russian 76.2mm gun could penetrate German tanks at distances up to 2,000 meters. The psychological impact on German tank crews was immediate and devastating. Feldwebel Hans Becker of the 11th Panzer Division recorded in his diary on July 3, 1941, "We have been deceived. Our leaders told us the Russians had only obsolete equipment. Today I watched 5 of our tanks destroyed by a single Russian tank we couldn't even damage. My gunner, Wilhelm, fired 23 rounds. Each one bounced off. Wilhelm wept afterwards. A hardened soldier who survived France and Greece reduced to tears by his helplessness." By late June 1941, the German High Command could no longer ignore the crisis. Hitler himself demanded answers, refusing to believe that Soviet engineering could surpass German technology. A special commission was formed, led by Ferdinand Porsche, designer of what would become the Tiger tank prototype, and including engineers from Henschel, MAN, Daimler-Benz, and Krupp. Their mission was to examine captured T-34's and determine how an allegedly backward nation had produced such a superior fighting machine. The examination team at Kummersdorf included some of Germany's most brilliant engineering minds. Each man arrived confident that detailed analysis would reveal critical weaknesses German crews could exploit. Instead, they discovered a masterpiece of practical engineering that challenged their fundamental assumptions about tank design. The armor analysis revealed revolutionary thinking that German engineers had dismissed as theoretically inferior. Thus, sloping armor at 60 degrees, Soviet designers achieved equivalent protection with half the weight of steel. Dr. Erwin Adis calculated that a shell striking the sloped armor had to penetrate the equivalent of 90 millimeters, while the actual plate was only 45 millimeters thick. Furthermore, the extreme angle increased the likelihood of ricochets, with many rounds simply skipping off the surface without transferring energy to the armor. Fischer spent 3 days measuring and analyzing the T-34's armor configuration. His report to the commission stated, "The entire design philosophy contradicts our approach. We add armor thickness for protection, adding weight that requires larger engines and stronger transmissions. The Soviets achieve superior protection through geometry, not mass. A Panzer IV requires 3,200 kilograms of armor. To achieve protection, this T-34 obtains with 1,900 kilograms. We have been thinking in 2 dimensions while they designed in 3. The hull design revealed brilliant simplicity that shocked engineers accustomed to complex German construction. The T-34's hull consisted of just 4 main plates, all sloped optimally, eliminating the shot traps that plagued German designs where incoming rounds could be deflected into vulnerable areas. Heinrich Kipkamp noted, "This hull could be produced by moderately skilled workers with basic equipment. Our Panzer III hull requires master welders and precise jigs. The Russian design achieves superior performance with inferior manufacturing resources." The suspension system provided another revelation. German tanks used leaf spring suspensions inherited from automotive design, limiting wheel travel to 150 millimeters and causing a harsh ride that fatigued crews and restricted cross-country speed. The T-34 employed a Christie suspension with large road wheels and long travel coil springs. Each wheel could move independently over a vertical distance of 500 millimeters. This allowed the T-34 to maintain 35 kilometers per hour over terrain that forced German tanks to slow to 10 kilometers per hour. Professor Porsche personally tested the suspension by driving the captured T-34 across Kummersdorf's obstacle course. His test report read, "The vehicle crossed trenches that would trap our Panzer IV. It climbed slopes that our tanks cannot attempt. The ride quality surpasses anything in our inventory." The gunner can actually aim while moving, something impossible in German tanks except on roads. We have fundamentally misunderstood the requirements of mobile warfare. The track system presented innovations that solved problems German engineers hadn't even recognized. German Panzer III tracks were 360 millimeters wide, resulting in ground pressure of 0.92 kilograms per square centimeter. The T-34's 550 millimeter tracks reduced ground pressure to 0.64 kilograms per square centimeter. This seemingly small difference had enormous tactical implications. During the autumn rains of 1941, entire German panzer divisions became immobilized in mud, while T-34's continued operating. The engine compartment yielded perhaps the most surprising discoveries. The T-34 used a V2 diesel engine, producing 500 horsepower from a compact, robust design weighing 750 kilograms. The engine was made of cast iron and steel using manufacturing techniques German engineers considered crude, yet this crude engine proved more reliable than sophisticated German power plants. The diesel fuel provided multiple advantages: 50% lower fire risk compared to gasoline, 30% better fuel efficiency providing greater operational range, and the ability to run on various fuel grades including kerosene, crude oil, and even alcohol in emergencies. Wolfgang Fischer studied the engine design for a week, documenting every detail. The V2's design philosophy contradicted everything taught in German engineering schools. Large tolerances between moving parts allowed for thermal expansion and contamination. Rough casting surfaces that would fail German quality control worked perfectly adequately. Simple splash lubrication replaced complex pressure systems. Fischer later wrote, "We Germans prided ourselves on precision engineering, components machined to tolerances of hundredths of millimeters. The V2 engine has tolerances 10 times larger, yet it works reliably in conditions that destroy our engines. They designed for mass production and field maintenance. We designed for perfection in a laboratory. Their approach works in war." The gun system provided crucial insights into Soviet design philosophy. The 76.2mm F-34 gun was a masterpiece of practical engineering. While less precisely manufactured than German weapons, it exceeded German tank guns in the metrics that mattered. The bore was chrome-plated, extending barrel life to 5,000 rounds compared to 2,000 for German guns. The gun's dual-purpose capability, firing both armor-piercing and high-explosive rounds with equal effectiveness, surpassed the specialized German approach, requiring different guns for different roles. Dr. Friedrich Krüger from Krupp studied the ammunition extensively. His findings challenged fundamental German assumptions. The Soviet armor-piercing rounds are simple solid shot, relying purely on kinetic energy. Our complex armor-piercing ballistic capped rounds are theoretically superior with better aerodynamics and penetration angles, but they require precise manufacturing that limits production. The Soviet rounds achieve 90% of our performance at 30% of the cost and complexity. In a war requiring millions of rounds, their approach is superior. Paul Ludwig Ewald von Kleist, one of Germany's most respected field commanders, called the T-34 the finest tank in the world. After encountering it in combat, Heinz Guderian affirmed the T-34's vast superiority over German tanks. Alfred Jodl, Chief of Operations Staff of the German Armed Forces, noted in his war diary, "The surprise at this new and thus unknown wonder armament being unleashed against the German assault divisions. The manufacturing analysis proved most psychologically devastating to German assumptions of technical superiority." The T-34 incorporated numerous innovations enabling mass production. Parts were designed with huge tolerances, allowing components from different factories to be intermixed. Critical dimensions were standardized across multiple components, reducing the variety of tooling required. Subassemblies were designed for testing before installation, catching defects early in production. Dr. Wilhelm Bauer from MAN conducted detailed production analysis. A Panzer III required approximately 6,000 man-hours to build in 1941. The T-34 initially required about 8,000 man-hours, but Soviet production improvements rapidly reduced this. By 1943, Chelyabinsk Tractor Factory was producing T-34s in 3,700 man-hours, while German tank production times increased due to growing complexity. The Panther required over 150,000 man-hours. the Tiger 250,000. Bauer's report stated, Soviet factories can produce 2 T-34s for every Panzer we build. Given the Soviet Union's larger industrial workforce and multiple production facilities, the actual ratio could reach 4-to-1. Mathematics, not tactics, will determine this war's outcome. The impact on German manufacturers was immediate and profound. At Henschel and Son, the entire VK 36.01 heavy tank project was scrapped after engineers realized its vertical armor was obsolete. The company lost 6 months of development work and 12 million Reichsmarks in investment. Porsche's competing design faced similar cancellation, with Ferdinand Porsche himself admitting in a private letter that the Russian tank has made 2 years of our work worthless overnight. At Daimler-Benz, the shock was particularly acute. The company had just received contracts for expanded Panzer III production when the T-34 rendered their entire product line obsolete. Chief Engineer Fritz Nallinger convened emergency meetings where engineers openly discussed copying Soviet design features, something unthinkable weeks earlier. The company's internal correspondence reveals near panic, with one memo stating, "We are at least 2 years behind Soviet tank development, possibly more." Mann's response was more measured but equally dramatic. The company immediately began recruiting engineers from civilian automotive projects. Recognizing that incremental improvements to existing designs were insufficient, they established a special team dedicated solely to analyzing captured T-34s and developing countermeasures. This team would eventually design the Panther, but not before experiencing what they called the humiliation of studying superior enemy equipment. 2 competing designs emerged for Germany's T-34 response. Daimler-Benz proposed essentially copying the T-34, including rear transmission, diesel engine, and sloped armor. Mann proposed a more conventional German layout, but incorporating sloped armor and enhanced firepower. The Mann design was selected, becoming the Panther. However, the Panther reflected persistent German inability to embrace Soviet design philosophy. Where the T-34 weighed 26 tons, the Panther weighed 45 tons. This weight increase cascaded through every system. Heavier transmission, wider tracks, larger engine, more fuel consumption, reduced strategic mobility. At the insistence of General Heinz Guderian, a special tank commission was created to assess the T-34. Among the features of the Soviet tank considered most significant was the sloped armor, which gave much improved effective armor thickness, the wide track, which improved mobility over soft terrain, and the 76.2 mm gun, which had good armor penetration and fired an effective high-explosive round. Intelligence reports in early 1942 revealed the scale of Soviet T-34 production. Factories evacuated from western regions were reaching full production in the Urals. Chelyabinsk Tractor Factory, nicknamed Tankograd, was producing 500 T-34s monthly by March 1942. The Stalingrad Tractor Factory, despite being under aerial bombardment, continued producing tanks that drove directly from the assembly line to the battlefield. German bombing couldn't stop production dispersed across multiple facilities. The T-34's cost-effectiveness transformed economic warfare. Each T-34 cost approximately 193,000 rubles in 1943. Equivalent to about 30,000 Reichsmarks. A Panther cost 17,100 Reichsmarks, nearly 4 times more. A Tiger cost 250,000 Reichsmarks, 8 times more. The Soviet Union could lose 3 T-34s for every Panther destroyed and still maintain economic advantage. This arithmetic of attrition doomed German efforts regardless of tactical prowess. The T-34's production statistics remained staggering even by modern standards. Approximately 57,000 T-34s of all variants were built during World War II, exceeding German total tank production across all models. More remarkably, T-34 quality improved while production increased. German quality declined as production struggled to increase. The Soviets ultimately built over 80,000 T-34s of all variants, allowing steadily greater numbers to be fielded, despite the loss of tens of thousands in combat against the German Wehrmacht. The T-34's design team, led by Mikhail Koshkin at factory number 183 in Kharkov, had approached tank design from first principles rather than evolutionary development. Unlike German designers who refined existing concepts, Koshkin's team questioned every assumption. Why must tanks have vertical armor? Why use gasoline engines? Why prioritize crew comfort over production simplicity? Why build tanks only specialized factories could produce? Their answers revolutionized not just tank design, but military manufacturing philosophy. Koshkin himself was dying of pneumonia contracted during winter testing when the T-34 entered production. He insisted on continuing work from his sickbed, reviewing production reports and design modifications until his death in September 1940. His deputy, Alexander Morozov, seamlessly continued development, demonstrating another Soviet advantage: design continuity through systematic documentation rather than individual genius. German design teams centered on prominent personalities like Porsche struggled when key individuals were unavailable. The Commission discovered that T-34 development began in 1937, with prototypes tested extensively in combat conditions during the Winter War against Finland. While Germany celebrated bloodless victories using tanks designed in the early 1930s, the Soviet Union was already mass-producing a revolutionary design incorporating combat lessons. By July 1941, Soviet factories had produced over 1,200 T-34's, with improved models already in development. German intelligence had dismissed reports of new Soviet tanks as propaganda. This intelligence failure cost thousands of German tank crew lives. Winter testing in January 1942 demonstrated crushing Soviet advantages in cold weather operations. The T-34 started reliably at -40°C using a compressed air system that didn't depend on battery power. German tanks required external heating or hand cranking in extreme cold. The T-34's wide tracks distributed weight, allowing movement over snow that trapped German tanks. Track grousers could be installed in minutes to improve ice traction. German tanks required hours to install similar devices. The diesel engine's cold weather advantages exceeded mere starting reliability. Diesel fuel didn't evaporate like gasoline, reducing fire risk when tanks were hit. Diesel exhaust was less visible than gasoline exhaust in cold air, reducing detection risk. The engine warmed up faster due to higher compression, allowing quicker combat readiness. German crews spent hours warming engines while T-34's were already maneuvering. The human cost of German failure to match the T-34 was staggering. Analysis of Eastern Front casualties showed German tank crew losses increased 300% after encountering T-34's. The psychological trauma was equally severe. Veterans described nightmares of green-painted slopes advancing while their shells bounced off harmlessly. Post-war interviews revealed deep professional humiliation among German engineers who had considered themselves world leaders in mechanical design. Training materials were hastily revised to address T-34 vulnerabilities. Crews were instructed to target tracks, vision devices, and the turret ring. These tactics acknowledged German inability to penetrate T-34 armor at normal combat ranges. The proud Panzer Force was reduced to mobility kills and mission kills rather than outright destruction. Even these modest goals required numerical superiority and tactical advantage. The Commission's interim report to Hitler in December 1941 walked a careful line between honesty and survival. They couldn't directly state Soviet superiority without risking accusations of defeatism. Instead, they recommended immediate development of new tanks, incorporating lessons learned from combat experience. This bureaucratic euphemism masked fundamental admission of German inferiority. The report triggered the development programs that would produce the Panther and Tiger, but these wouldn't reach the battlefield in Tatosium. Significant numbers until 1943, 2 years during which the T-34 dominated the Eastern Front. Dr. Erwin Adis's final report on the T-34, written in March 1946 for American Intelligence, provides insight into the philosophical transformation the testing forced upon German engineers. The T-34 succeeded not through individual excellence, but through systemic optimization. Every component was adequate for its purpose, No more, no less. The design was optimized for production by available workers, maintenance by available skills, operation by available crews, and combat in available conditions. German tanks were optimized for theoretical excellence that reality never provided. The T-34 won because it was designed for the war that was actually fought, not the war we imagined. Heinrich Kiepkamp, who oversaw German tank development throughout the war, admitted in his post-war interrogation, "The T-34 was the best tank of World War II. We could build better tanks for tank schools, better tanks for parades, better tanks for individual combat. But for winning a war of mass armies across vast distances, nothing matched the T-34. We learned this too late, after our fate was sealed." The philosophical divide between German and Soviet design approaches reflected deeper cultural differences. German engineering culture valued precision, complexity, and perfection. Individual excellence was paramount. Soviet engineering culture valued adequacy, simplicity, and quantity. Systematic effectiveness was paramount. The T-34 embodied Soviet philosophy, while German tanks embodied German philosophy. In total war between industrial powers, Soviet philosophy proved superior. The story of German engineers testing the T-34 ultimately transcends technical analysis. It represents the collision between two worldviews, two approaches to problem solving, two definitions of excellence. The German engineers who measured, tested, and analyzed the T-34 were forced to confront the limitations of their own thinking. Their journey from dismissive superiority through grudging respect to genuine admiration mirrors the larger German experience on the Eastern Front. Wolfgang Fischer survived the war and spent his remaining years reflecting on lessons learned. His son, also an engineer, preserved his father's notebooks from the T-34 testing. The final entry, dated May 8, 1945, reads, "The T-34 taught us that elegance in engineering is not complexity but simplicity, not perfection but adequacy, not individual brilliance but systematic competence. We who thought ourselves masters were revealed as apprentices. The T-34 was not just a better tank, it was better thinking about tanks, and that made all the difference." The captured T-34 that Wolfgang Fischer examined on that July morning in 1941 represented more than enemy equipment. It was physical proof that German assumptions about technological advancement and military destiny were catastrophically wrong. Every measurement he took, every test he conducted, every calculation he completed drove home a simple truth. Soviet engineers had outthought, outdesigned, and out-engineered the vaunted German industrial machine. The pencil trembling in his hand that morning was not from excitement of discovery, but from recognition of defeat. Not just military defeat, but intellectual and philosophical defeat that would reshape how engineers thought about design for generations to come. Today, T-34s stand in museums worldwide, monuments not just to Soviet manufacturing or courage, but to the power of correct design philosophy meeting the actual demands of total war.